Streaming. Let's start streaming. Okay, so this is good. Um, okay, I'm Shiv. I am gonna be talking about GPU stragglers and just wanted to understand how nickel works. So I'm gonna work on doing like a toy nickel implementation. So before I do that, I'm just gonna ensure my stream is properly set up. There's a good chance that I've already just like made this private. So no, not this, not this, not this. Come on. So live streaming. It does say it's connected to some stream. Uh, Give me a few seconds though. I am trying to understand if my stream is private, which is which is the case. It seems private, and I do have the option of just making it public at some point, right? Okay, how do I know if it's like private or not? Okay, this is stream settings. Okay, this is privacy. Dude, this is so weird. Like, okay, oh, so they only allow you to you know what? It's fine. I'm gonna probably just make this public right now and save this. Ooh, okay, okay. So there is definitely some lag, and that's fine. I think that's completely okay. I'm gonna close this window. Let's come back to the stream screen. Let me perhaps show my stream browser. Boom. Okay, cool. So let's first talk about what I'm trying to do. I am trying to figure out what causes GPU stragglers, and yeah, I think I'm gonna try to implement nickel uh, from scratch. But before that happens, why are stragglers even important? So perhaps I can give you an example of like a training log. So this is like a text dump that I got from like a training job. So this on the right is an ML training job, and you can see that there are a bunch of steps. Like it logs every 10 steps and then gives you a dt, which is like a delta of like how long it took for these 10 steps to finish. And then you kind of see that most steps are like 8.9 to 9 seconds, but then there are like these four steps that took surprisingly long amount of time, which is like 21 seconds, 48 seconds, and so on. So this is a pretty small like GPT-2 train job. So uh, it's weird that most steps take like a pretty deterministic amount of time, like pretty tiny amount of like DT, but everything, but these few steps had like an inflated step time. And why is that bad? So before I tell you why that is bad, perhaps it helps to understand some overarching ML jargon. So ML training jargon maybe. So you need to know of a few things. So first is like world size. This is number of GPUs that you are using to train a job. To train a job, this is important. So world size is a concept for a train job, and this is just going to be the number of GPU cores you have in your training job. Then there is the rank, which is the unique num for a job. I just hope I'm sharing the right screen. Okay, I am sharing the right screen. So, unique number for a job worker, I will say. So, ranks usually go from 0 to n minus 1, 0 to n minus 1. and then yeah, your total ranks are going to be just n being like the number of GPU cores for your job. So you can see this one is rank 0, so literally means that there is one uh like if my world size was n, this is literally the very first GPU core that is assigned to any work, any training work. uh and perhaps what also helps is understanding like the overarching steps that go into like a training job. And I'm gonna dumb it down significantly. So overarching steps. So first, when you get an ML, when you start an ML training job, you will have you'll have to load all that. You'll have one large training data set, and then you pick out like tiny chunks of uh, training data from um, yeah, you pick out tiny chunks of uh, carve out like tiny chunks from this training data, and you assign it to each rank. So every rank will have like some finite amount of data, so you can just be like, hey, load chunks of uh, training data into your uh, workers, and say this is going to be a desk IO operation. There could be like checkpointing at some point, but that's also going to be like disk IO. But that's like the very first step. Like you load some training data, and then you do the forward pass. So forward pass. I'm gonna call this like a compute step. Like this is just where raw computation happens. Then yeah, then you do like the backward pass, of course, and you're basically getting the gradients at this point. And let's see if okay. So this is also gonna be compute, um, and perhaps like if I can. So okay, between like if I were to just be pedantic, it's like gonna be the compute loss, which is also gonna be compute. And then there's backward pass, which is gonna get okay, generates the gradients. Now that you have gradients like this, for now, step 1 to 4 is completely isolated to one particular worker. There is nothing else that has left the GPU, that has left the particular node or that GPU core. It's all happening in that one worker. So the next part is actually called synchronize gradients. This is a network call, and then once your gradients are synchronized, this is where last step would be like optimizer step, which is again a compute. Uh, so these are like the overarching steps, and then to like dumb it down further, so ML training, oops. So an ML training job like breaks down into three modes. Like I would say, desk IO, which is like uh, data load plus uh, maybe checkpointing. I don't know, like read write basically. Okay, and then there is the compute. Oops, compute, which is literally the forward pass, the backward pass, the computing loss, optimizer step, and so on. And then there is the network step, which is like sure, some initial uh, time does go into like loading the model and model weights and so on. That could involve network call, but the harder part is like synchronizing gradients. That's the uh, um that's the network part. So now that we have this, I think this is like the the bare minimum ML jargon that we need to know in order to like understand what stragglers like to understand what exactly is happening in this log. So coming back to this log, uh, every time like you if you look at the logs for any rank, you would see the same inflation in uh, step duration for every single rank that is in your cluster at the at exactly the same time. And like suppose like let's say that your ML training job per step takes like X seconds. uh, Shitty napkin math, I guess. So if your single step, say, takes like X seconds, right? Uh, but like like this is oversimplification and a pure thought. Okay, thought experiment. So this is like a pure thought experiment, but like say a single step, say tech takes like X seconds, and then every say uh, every 10 steps, like your latency for the step goes up by additional y seconds. So what that means is that on an average, on an you're kind of taking on an average you're taking like x plus uh, y by 10. Okay, you know what, like I think markdown supports like fractions, so it's like x plus. So this is gonna be like the average amount of uh, time spent per step. Now you now the problem with this is like if I were to like literally like substitute these values, like I know my x is like um, say my x is like 10, but okay, x is say 9, but say y is like 40, which is like right here, right, like this 40 48. It I mean, I'm just like taking like a simple example. It's like 48 between like 21 to 48, but just for the sake of simplification. So this is basically my average time goes up to uh, goes up to like goes up to like around 13 secs per step when originally it was just like 9 steps. Now you could argue and you could be like, hey, like, is that really a big deal? And you have to remember that ML training jobs run for a very long time. Quick check on my OBS health. Last time I was streaming and then I realized that shit just did not work. Uh, like 10 minutes into the stream, my stream had broken, and then I was like just streaming and talking into nothingness for like the next 1 hour, and then I just gotta keep doing these health checks. Cool, my stream is seems healthy. So ever training jobs run for a very long time. So like GPT-3, if I remember it correctly, had like 268k steps, and what this means is that your extra that additional time is that you're seeing here significantly adds to your significantly adds to your training time. So uh, if your step per step time is going up by like some additional like y, and y is like large enough, then it means that your training job just gets extended by several weeks. And then you could argue that okay, let's note this down. Training okay, uh, high y means significantly longer training time. So uh, is that bad though, given these jobs run for months? No, that's a good question. Like, is it bad? But uh, it could be justified if your CPUs were actually if your GPUs were actually crunching numbers or doing anything useful during the time during this spike. If your GPUs were actually doing something useful, it would be justified. You could be like, okay, sure, my GPUs just need extra time. But during this spike, during this spike, your GPUs are just sitting idle, and that's what we will like get down into. So like, it's basically like your training job has extended by uh, like say 2 weeks because of these weird inflations, and then those few weeks of additional time is just your GPUs sitting idle, if that makes sense. And I'm gonna make this maybe a little more clear over time, but that's what happens. Uh, and you generally do not want to leave like maybe a GB 300, GB 200 running for uh, I don't know, a couple of weeks, for example. Just gonna be extremely inefficient and gonna cost a lot of money. So that's the general motivation. But like what I didn't say was why these GPUs are idle. Okay, let's maybe note this down. Yes, your GPUs are okay. Most of your GPUs are just idle during this spike, so low key uh, bad thing to leave them running for like I don't know 300. Okay, okay, leave GPUs running uh, for a few weeks, I guess. I don't know. I'm just making rough points so that later I can like could put this into like a blog, I guess. But that's the idea. Now we will talk about like let's like draw up like a diagram for how these jobs would work. So I'm gonna draw like a sequence diagram of sorts that kind of shows how uh, like an ML training job occurs, and then I'll focus on like what stragglers actually do. So let's see. Oh my goodness, I do not like this line style, dude. This is just how do I change this stroke style? Okay, what is this stroke style, dude? This is solid. Come on, dude. Okay. I mean, I do like Excalibur, and then I'm just gonna be like, it's fine. It's fine. It's fine. It's fine. Okay, so let's maybe before I draw boxes, I wanna see. Okay, perfect. So this text size is pretty good. So let's say world size is 4, which means that I have 4 GPUs in my cluster, and then let's say ranks are 0, 1, 2, and 3. Okay, so say this is uh, what I have. How do I like make this like aligned to one side? Okay, this makes sense. Okay, perfect. I am sharing my browser, I hope. Yep, I am sharing my browser. Last time, like I've done a bunch of streams where I'm just like sharing the wrong things, and yeah, that's never good. So I'm gonna create like a tiny diagram to like kind of explain. I have like nothing better to do, so rank 0, oops, rank 1, rank 2, and then finally say rank 3. So these are my 4 ranks, and then I'll just like copy this, and then because it's a sequence diagram, I'm just gonna like place it here like this. Cool. And then let's see if I can. Okay, so my lines are clearly like not perfectly aligned, but I hope that I can align this a bit better. So this is a sequence diagram. That's how I like to visualize like an ML training job and all its steps. Okay, so first of all, I've done this. what gives me an ick is this thing. So if I like, does this look straight? This kind of looks straight, right? Okay, whatever. We did not need to die on that hill. So let's put. Okay, you know what? Sorry, I am so sorry. I wanna like see if I can extend this down. Okay, I can do that, and that does work really well. Okay, perfect. So like first we know that there is the forward pass. We compute loss and then backward pass, which is gonna get us the gradients. So perhaps I'll like just draw that here. How do I do like a self thing? Do I have to like do it myself? So maybe okay, this is just difficult, but do they have like different types of arrows? What is this arrow? Okay, maybe this arrow is just oh, there is no way I am spending this long on just drawing arrows. I am gonna just use my. Okay, perfect. So this is my arrow, and then uh, let's copy paste this every. Whoops! Copy paste this here, and then maybe this here. Okay. Okay. Awesome. So I'm gonna uh, call this whole layer. Uh, okay. So because I am kind of lazy that way, I'm just gonna be like, okay, let's just call this entire thing. Can I send this to the back, please? Okay, cool. This kind of worked. And can I fill this shit with something? Okay, cool. This works. Okay, cool, 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 cool. So, cool. I'm gonna call this thing as let's see. Okay, so it should just be like forward pass plus um what does happen? Compute and loss, right? Okay, compute loss plus backward pass, which is get gradients. Okay, cool. Oops. Can I like kind of shrink this shit? Okay, perfect. This is good. This is good. Okay. Okay. Kind of like this maybe, and then uh I'm gonna maybe create one more text field over here, and then I'm gonna call this compute. Just compute. So just so that we know like what this entire block is supposed to do, and then maybe extend it a bit more, I guess. I could definitely do like a mermaid diagram, but I do not care enough. Uh, I kind of like this more. Okay, so this is the first step. This is like the compute pass, and now this is gonna be like the next part is gonna be kind of like the harder thing to explain, which is how we'll actually know if your GPUs are working. Like, and these ranks, you can just say that these are my GPUs. Okay, these are my GPUs. That's all you can say. So, this is your uh, compute, like coming back to this like oversimplification where we broke down ML training job into like these three modes. I'm just gonna just top focus on computer network. So this is one, and then we will do something else here, which is oops. This is gonna be like the network one, which is basically when your all reduce operation happens. So let's talk about all reduce, and I think for all reduce, I'll probably like do like a different color scheme. Maybe is there like a decent color scheme that I can? Uh, this is kind of better. Okay, this is like much nicer. Okay, before I do that, I gotta extend the base a little more, because no. Okay, cool. So, okay, we gotta push this down a bit more. Okay. Um, keep pushing. Okay, this should have enough room, I guess. So I'm gonna maybe label this as network. This is network, and then okay. So this is network. Quick check on my stream health. The stream does seem to be working well again. Happy, pretty happy. Cool. Now that we have all these three things, right? We have all these three things. Uh, the okay. Let's quickly talk about like what an all reduce operation is. So when you do like a uh, gradient sync. So this is where your gradient sync is gonna come into the picture, and then what is gonna happen during gradient sync under the hood is just gonna be an all reduce operation. So uh, perhaps like something that is worth mentioning here is that when you are say uh, configuring your ML training jobs, you can uh, like okay. Sorry, one quick step back. I'm still new to streaming, so please bear with me. So Nikhil, what exactly is Nikhil? I'm not gonna go deep into it, but Nikhil NVIDIA. So it's a collective communications library, and it's basically the way NVIDIA. It's an NVIDIA library that allows you to like facilitate inter GPU communication. So that's how you use Nickel to exchange gradients across your nodes. That's the idea behind Nickel. So Nickel, let's say, okay. Nickel transports. I think this is like another important concept that I think you should be aware of going into this. So, what happens when you set up your training job is that uh, you will have some nickel libraries installed in your machine, which on your literal node, and when your training job is starting up, the nickel library is gonna recognize the most optimal network path, and then it will pick those paths for like exchanging weights or doing any inter GPU multi internode communication. So generally, what happens is like you in your logs you will see something like I think it's like nickel transport something like net socket, for example. If you're like broke like me and do not have an EFA devices, like you will see like TC. So like I'm just gonna write out like the various nickel um, transports that are kind of relevant here. I won't list out all of them, but like some that I know of. So nickel transports like you'll have the basic like which is like TCP over ether ethernet, which is gonna be the oh my goodness, bro, like, am I just like spelling Ethernet wrong? Anyways, fuck that. So this is like the slowest, and then I think slowest, and I think this is like for internode. So okay, nickel uh, comms between GPUs and between nodes. So remember this, like you'll have instances where there are multiple GPUs on the same node, and then you will also have instances where there are multiple GPUs scattered across nodes, and then your ranks generally are just not uh, they should not generally care where your instances are. It's like Nickel offloads that takes on that responsibility, finds the fastest path of exchanging weights between say rank 1 to rank 2. If rank 1 and 2 are on the same node, it's gonna use something called NV-link, which is like GPU to GPU communication. But if it's like complete, if your nodes are like across uh, GPUs are across nodes, then it's gonna use something called EFA, or like something that's new that's coming up is like RDMA, which is like remote direct memory uh, access or something. I think uh, I'm probably fucking it up, but that's the idea. So uh, we have the most basic, uh, which is like net socket, which is like the default transport that Nickel will fall back to when it's trying to when it just does not have the necessary hardware network interfaces to like do any of so sorry, when it does not have necessary network interface. I don't know how to explain it. Why am I suddenly so bad at like explaining things? Okay, I'm gonna give it one more try. So Nickel is gonna fall back to net socket if it does not find that your instance has like EFA devices attached, or it's just a shitty instance and no other no RDMA libraries either. So it's just gonna fall back to net socket. This is like the most basic ass uh, transport that you'll have. Then you'll also have something called, I think, net IB. This is the new thing, which is InfiniBand. And I think it's like this is again internode, pretty fast. What am I doing? IB. It should be IB here, and then there's, I think, net EFA. This is very AWS specific, but that's what I know. And then there is also something interesting called P2P, say NV link, and that's how this is like internode. NV link is just this goated thing that allows you to like do direct GPU to GPU like communication. So these are like your basic Nickel transports. How do I make this shit bold? Like just this part, because this needs to like kind of stand out. Oh no, no! I can't do that. Okay, anyway, that's fine. So these are like basic Nickel transports that you need to keep in mind. So when Nickel is synchronizing gradients across these ranks, it's gonna use one of these transports, and I'm just gonna focus on net socket because it's just very easy to simulate in like a if you were to build a toy Nickel all reduce, then you could just use like net socket. So this is what we want to use. And then you have this operation called gradient sync, which is when all ranks decide to like start uh, exchanging their gradients, and then it basically is just this. So you have an uh, all reduce operation, and this under the hood is just two things, which is like one is an all scatter where your like the first is like an all scatter where all your ranks will pass their chunk to the next node. So it's like all scatter, give your chunk, oops, to the next rank. You keep doing this, and then you have like all gather, which is basically um, yeah, which is just basically gathering, get the reduced uh, chunks. Okay, so like to kind of like visualize this, This is gonna be like a bit hard to visualize, I guess, but uh, so okay. So what nickel does when it like initializes, when you initialize your world, is it creates something called a ring. So nickel will create this nickel topology is what it's called. So this is like the nickel topology, and then you have like rings, which is like this is just something that you can literally find in the logs when your job's like booting up. So it's like the ring in this case would look like 0 goes to 1. Okay, so this 0 goes to say 1, say goes to 2, goes to 3, and then 3 goes back to 0. So it literally is forming like a ring. So it's like literally uh, like a ring in which each node is gonna be like each rank is gonna be exchanging data with each other. So this is like how a ring is created, and then there is something called channels. So oops, there is something called channels, which is like uh, independent rings uh, per okay, independent ring per channel, I would say. So like if your nickel topology has like two channels, then it means that there are like two rings, two identical rings where data is probably being like split up, and then the all reduce and all gather is just happening in these like two channels. So that is uh, what you care about. In this example, we'll just like assume one channel only. So I'm just gonna assume that we have like a single channel here, and then what does like an all reduce operation look like? Let's do that. That's gonna be the fun part. So training every rank is gonna have a chunk, as I said, that it's gonna uh, uh, push through the forward pass, get lost, get the loss, compute the loss, backward pass, and get the gradients. And like, once you have the gradients, it's just, oh my goodness, dude, like what the fuck is this line? Okay, how do I make the line better, dude? Like this is just such shit line. Okay, this I need this line. Okay, so this is one, dude. What is this line, dude? Okay, hold on. Let's try this one maybe. Okay, this is I don't know what's the difference, but fine. So this is say me creating, dude, what? Why? Okay. So say I am uh, using my 0th chunk and like pushing it forward to sending it to rank 0. This will keep repeating like so. Oops, it gives me an ick that these are just not very well. Okay. And then you'll have one final thing that will go like this all the way back over here. So this is the ring, right? So uh, rank 0 sends its chunk to rank 1. Rank 1 sends its chunk to rank 2. And rank 3 sends its chunk to, say, rank 0. And then and then let's say I'm gonna like kind of like, oops, this is just fucking everything up, huh? Okay, I'm gonna compress this a bit because I don't know, like just gotta do it. And this goes up here like so. This goes up here like so, and then this shit goes up right here like so. Okay, perfect. So now that you have this, this is like one iteration. So rank 1 now has its own chunk and chunk 0. Rank 2 has its own chunk and chunk 1, and so on. So like uh, every rank at this iteration has like one uh, chunk, and we are not happy with just this. So uh, oh my goodness, this selecting shit in this tool is just so hard. So I think I first have to select the arrows because those are the easiest to grab, and then the text. Okay, perfect. Now that I've done this, I'm gonna repeat this again because I need to get all my chunks across. So I'm just gonna like inflate this, and of course I have to like extend this blue fucking box, but I will do that. Dude, what is happening here? Like, why does this shit move? Like, okay. Okay, perfect. So now that we have this, okay, time to fix this arrow, I guess. Just so painstaking to like make any of these diagrams. Okay, perfect. So this was like the first pass chunk 0 went to rank 1, chunk 1 from rank 1 went to rank 2, and so on. And then you will see that uh, rank 3 sent its chunk to rank 0. And then what is gonna happen is, dude, what the fuck? Dude, what? Like, this is just annoying, dude. Like what? Like, I really had high hopes from this tool, but this tool just keeps bugging on me. Okay, anyway, sorry for being frustrated. So now that chunk 3 sent, rank 3 sent its chunk to rank 0. I'll come to what these chunks are. And this is just getting accumulated. So this is like accumulated, and then now rank 0, rank 1, which had previously accumulated chunk 0, is gonna send its accumulated rank forward. This dude is just gonna be like, okay. So in the subsequent passes, you can see that every rank is passing their accumulated chunk back. So 2 is gonna be ACK. So this is like the second pass, and then for like the last pass, I would say this would just be like, okay, I had like rank 3 had accumulated chunk 2, and which is what it sent back to rank 0. So rank 0 is now gonna forward the accumulated chunk 2. Okay, what am I doing? ACK. And you can see that in the previous run, chunk 3 was sent to rank 1. So rank 1 can now forward the chunk 3, which was accumulated by rank 1. And then in this pass, you will see that immediately above rank chunk 0 was sent to chunk to rank 2, and then rank 2 can now forward that accumulated chunk to whatever is the next rank. And then finally we have chunk 1, which was accumulated by rank 3, which is being sent back to rank 0. So now in all of these operations, what has happened is every rank now has all the chunks. So rank 0 had its own chunk. In the first run, in the first pass, it got like chunk 3. In the second pass, it got chunk 2. In the last pass, it got chunk 1. So it has like chunk 0 to chunk like 4. So so all gather and all reduce. Like so all gather, you can see that it took n minus. So it's like, maybe I could just like write it here. So it takes like a big O of n minus 1. What am I saying? What big O of n minus 1 makes 0 sense. It takes n minus 1 steps to get to okay, steps for each rank to have all the chunks. And the chunks, what the fuck are these chunks, you might ask? These chunks are literally just like vectors. If I were to like say, how do I draw it out? Let me draw it out real quick. I have it somewhere in my text dump, maybe. Should I draw it over here, maybe? Oops, no. Quick check on my stream health. Stream health is healthy. Okay. Rank. What are the, okay, chunk. So just gradients. Like I don't think we need to like uh uh overcomplicate this, but say rank 0 is just gonna have like A0, A0, A1. What am I doing? Hold on, give me a sec. I need to fix my internet real quick. Maybe should I? Oh my goodness, I could have almost doxed myself. Wait, I can't dox myself, I think. I'm gonna give it a try. Okay, perfect. So, me checking my Wi-Fi settings. I did not want anyone to see what Wi-Fi network I'm using. Good, good. That's not gonna happen then, huh? Okay. Give me a sec, give me a sec, give me a sec. Sorry for the interruption. I'm trying to like fix my. Okay, perfect, perfect. I think I have slightly more stable internet now. So coming to ranks, coming to chunks, like so say rank 0 gradient, for example, say looks a bit like this maybe. So say rank 0 gradient looks like, what am I doing? So say it looks like A0, B0, C0, D0, and then say a rank 1 gradient is just this, A, B, whatever, right? Like just an illustration. So just literally checks are just gradient, I don't know, vectors, and so these are just like gradient vectors. I'm just taking like an example, and then and all scatter. I'm gonna be like dot dot dot, because that's how it is. For example, all gather is just like the trip it takes to like uh, sum it up. So like a reduce literally just means okay, maybe this would be a better way to explain it. Reduce is just a sum of all these across ranks. So what it means is uh, the goal that we want with this vector is like every rank ends up with a0 plus a1 plus a2 plus a3, and similarly b0 plus b1 plus b2 plus b3, and similarly like c1 plus c2 plus c3 plus c4, and similarly like d0 plus d1 plus d2 plus d3. Oops, this is kind of stupid because I kind of like fucked it up. This should be right. So goal, every rank has this, and start state is this. So start state is this. So it's like, okay, every rank currently has just a zeros or like what its own local gradient, and the reduce is just like sum of all say gradients, all these gradients across these ranks. So this is literally the goal state. And how do you get to the goal state? So like if I were to go back to say so if I were to go back to like say round 1, like where we are passing chunk 0 to the rank 1, and then like passing our own chunk to the next rank, this first pass. So if I were to come back here and show you what happens next, so round 1 of say all like round one of say a scattering is just gonna uh, be like chunk zero is just gonna map to this particular thing, and it's gonna send that to rank one. So R0 sends A0 to R1. So that's like this is my chunk basically, and R1 sends R1 sends like B1 to R2, and R2 sends C2 to R3, and R3 sends um, whatever like D3 to R0. So like at the end of round one, I kind of have like so like so like at the end of rank one, what I kind of have is sorry, end of round one, I have end of round one for rank zero. For example, just for simplification, right? Like A0, I have A0, I have B0, I have C0, and I have D0 plus D3. Does that make sense? And like similarly for like say the next rank that occurs, like which is like rank say rank one, it's just gonna be like uh, yeah, it's just gonna be A0 plus say A1, and oops, this is gonna be one, this is gonna be one, and this is gonna be one. So you can see that in my very first round, uh, I got like two elements from my rank. Like this is the goal state, right? This is like the goal state, and then like at the end of round one, I'm just doing all of this, and then you keep doing this, uh, and then at the final round, you have all final round. You kind of get the point, right? Like uh, everyone is just gonna eventually get all these chunks. So like for this particular rank, I have okay. You know, this is gonna be interesting. This is gonna be really interesting. So once I have like at the very final round, uh, rank zero, final round for rank zero. Like a very subtle thing to notice here is that at the final round, rank zero basically has this D0 plus D1 plus D2 plus D3. And okay, final states after all n minus 1 rounds for all ranks. So say R0 just has this. Uh, right now you can see the problem, right? Like my goal state is this, but I am not exactly at goal state. So I'm like, okay, R1 I knew was accumulating all A's, so A1 plus A2 plus A3, and then you can see like whatever 1 and gonna be like D1. So this is what's happening in R1, and then like R2 you can like kind of see that uh, this is gonna be A2. Like R2 rank 2 is gonna keep accumulating all the B's, so it's gonna be B0 plus B1 plus a B2 plus a B3, and then finally rank 3 is gonna have just A3, this is gonna be B3, and this is gonna be like C1 C0 plus C2 plus sorry C1 plus C3, and then finally D3. So like all these ranks, you will see like at after n minus 1 rounds, which was like the scattering stage, everyone had just one, everyone was able to accumulate like one tiny chunk. So this is like the first thing that you are kind of getting. So I'm probably gonna paste this in there. So maybe like I don't know if I should be like dumping this in here, but okay, maybe dude, this again, this is just so annoying. Like this is just so annoying. Okay, anyways, this is somewhat good. Okay. So I'm gonna be like, okay, let's see, start, start. I don't know if this is a good idea to like write anything in here, but I just wanna see if I can, just for visualization. It's like it's really good to have something to look at, and then can I like kind of shrink this shit? Okay, sure, I guess. Okay, so I'm gonna do the hard work and just gonna do all of this A2, A3, B3, B2, 2, 3, 3, and 2. Cool. So this is my start, and then my goal is this, right? Goal is this. So goal is every rank has this. So my goal is this. This is my goal, and then uh yeah, maybe this is what we're gonna put here. So final states of, yeah, this is easier to like visualize now. So final states of, for all ranks after n minus 1 rounds of all scatter. So uh this is what's happening basically. So I'm just gonna make, dude, this is so annoying, dude. Can I like change the background for this? Like, can I really though? Huh. Like, it would be nice if this was like slightly different color to stand out, but it's fine, I guess. Maybe I could just change the text style, like Comic Sans. Oof, that would be bad. Dude, Comic Sans kind of looks good. Comic Sans unironically looks good here. Like, really well formatted. Okay, you know what? Like, we commit to Comic Sans, I guess. Oof, shit, dude, this looks. I don't know what to feel about this, but this kind of looks suspicious. So, okay, fine, whatever. So you can see that at after like our uh, all scatter operation, like every rank has like 1/4 of all the necessary goal data. So like A has collected, rank 0 has collected all the D terms, rank 1 has collected all the A terms, and so on. So now that was just the all scatter stage. Boom. So the next thing that you probably have guessed is we are gonna do yeah, the next step that you probably have guessed is that we're gonna do a all gather. So it's like you have first uh in the first stage you split all your ranks. Sorry, my bad. Give me a sec, I'm just like fixing my Wi-Fi. Keeps messing things up. Okay, I'm back. Okay, so in the first stage of all scatter, we we got to this final state, which is like exchanging your chunks and then like just pushing them all to whatever ranks we have in the ring topology. So this is basically how the ring topology works. And then what we will do next is what we'll do next is all gather. So like we have spread all of our uh, like partial uh, sums, right? Like all of these are just like partial sums, and now we need to uh, have the complete sum. So like everything has like just 1/4 of the full result. And now because we want to have the entire result, now because we want to have like an entire result, we will do the all gather operation, which is just gonna be another network call. But let me just push this down a bit more, bit more, bit more, a little bit more. Keeps going down, keeps going down, keeps going down. Okay, perfect, 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 perfect. Now that we have all of this block, I am low-key scared, but let's see if I can just copy this entire block. Oof, that just hurt, bro. Okay. I'm gonna do this, and oh my goodness, I kind of realized that I can't like just okay, let's try this then. Like if I do send to back, just this chunk send to back, does this kind of work? Okay, 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 perfect. It kind of does work. Adjust it a bit too harshly, I guess, at the start. So I'm gonna call this network as all reduce 1 of 2, which is all scatter. So this is like all reduce 1 of 2 all scatter, and then this one's gonna be like all reduce 2 of 2, which is gonna be the gathering stage. All gather, I'm guessing. Okay, this could be like an oversimplification. Like I may have gotten some terms wrong here. Like maybe all gather is called something else, but I am simply explaining the overarching like the concept here, like exactly how this thing happens. And then I'm gonna use like a different color for this. Maybe let's do like a lighter color of green. Maybe still a network call. Don't get me wrong, but I just wanna show that it's like different from the other ones. And then instead of calling this like a chunk, I'm just gonna call this like, hey, I'm reducing. I am reducing. Okay. Oh, I realize this is gonna be too painful to do. Reduce. Reduce. Okay, if I align these well, and then if I just like, I don't know. Should I be doing it in such effort? Don't know. Okay. Sorry. So, uh, shit. Okay. So I wanna do. So we're starting with this now. Goal is to get here. And then we don't need this section anymore. But anyway, so after you do the very first round of reduce, you're literally gonna be like exchanging like R0 is gonna be like, hey, I have all the uh, R0 is gonna be like, hey, I have all the A terms collected, and I have all the B terms collected and C terms collected and so on. So just gonna keep doing this. And I think and I think that one important distinction is that they are like uh, I think one important thing to note is that like I'm gonna call this question mark because it's like they do not have these chunks. So I do not want to like kind of like mislead anyone. Like it's like me showing D1 there doesn't mean that it has like D1. It's like, hey, I'm just waiting for things. It's like, oh, so it's like that state representation is like, okay, I'm waiting for these things. So I want these things, right? But like this representation, it kind of gives you an impression that I have a vector which has a0, b0, c0, and then sum of d. So begs the question of why would uh, why would I do a reduce operation, exchange my partial sum, and then wouldn't I have like two a0s uh, eventually when I am exchanging things? Wouldn't I have like twice of one uh, chunk, which is not the case. So I just want to like clarify that every at the end of all scatter, every rank just has like one fourth of all the partial just partial sums of like the entire goal state, and just like one fourth of the entire goal state. It does not have so just that's why I'm gonna have like a question mark over here, but that's the idea. And now that we have this, I'm just gonna be like, okay, ah, reduce. I'm gonna get rid of the word "ac" because it just gives you the wrong connotations, I guess. Like really, accumulation is a very special like math operation, so I would not want to do that, honestly. Reduce. Boom. Boom. Okay. Reduce. Here is reduce again. I don't wanna like do this. Again, the operations are gonna be the same. This is gonna be again reduce. Okay. Oh my goodness, bro. Just because I am a bit okay, so I'm gonna get rid of this shit. It's like, okay, whatever. So I'm gonna perhaps like do like at the end of say, so after round one, you should be able to see uh like after round one, you can see that rank 3 is gonna be able to send its chunk, like this thing. Rank 3 is sending its chunk to rank 0. So after round one, the state you should have is kind of like this. And then we know that uh, rank 0 sent its chunk to rank 1. So this dude's gonna get some. Rank 1 send its information to, say, sent its sum to rank 2. So this dude's gonna get this. And then this dude's gonna be rank 2 is gonna sending its partial sum to this dude. And then that's pretty much how it's gonna work. And then I'm gonna shift this a little to the right, I guess. Left. I meant left. Not directionally challenged, guys. Okay, so after round one, you will see that we have this state. And then after we do this, we spend like again n minus one more steps. Okay. How do I Oh, okay, I see now. Okay, I gotta move these things, I guess. Oh, fucking hell, bro. Like, this is so fucking annoying. Okay. This probably goes down here. Somewhere over here. Okay, perfect. This is how it's gonna work, I guess. And then you get the reduced chunks. You take another n minus one steps to to collect all the partial sums, and then all reduce in total takes uh, 2n minus 1 steps, where n is the number of ranks uh, in your system. So That's basically the general idea. And then I'm gonna probably like copy this entire section again, because this just goes down here again. This just goes down here again. I'm gonna call this shit. Okay. And this is the final step for optimizer step. You know, uh, that's what it is. And then I'm gonna color code this. I'm gonna be like send to back, and then maybe we could have like the same weird yellow color over here. I guess that should be okay. So perfect. So before I kind of like lose this, I'm just gonna save this because I think this is like just useful information. I wonder if in an attempt to save, am I just gonna like fuck things up? What? Dude, my stream kind of died, it seems. What the fuck? I'm gonna do a quick check if my stream is actually on, but I'm gonna save this shit. Yeah. Diagram. Save the file, I guess. Okay. Okay, time to check if actually things are working. Oh man. Oh man. Okay, I'm just gonna open up a new browser. Optimizer step. Uh, that's what it is, and then I'm gonna color code this. I'm gonna be like send to back, and then maybe we could have like the same weird yellow color over here, I guess. Okay. Cool, perfect. So my stream is working. At least that's what I see from my other browser. So I think we should. Okay. There we are. Like, okay, my OBS now says that it's all excellent. Perfect. So, okay, perfect. So this is the foundation. I think this is this is what I meant when I said like the oversimplified like modes in which your training step operates. It's like compute and then network. So what I wanna now talk about is yeah, okay. What I wanna now talk about is stragglers and what your GPUs are doing. Like this entire section that you see here, when your network is doing something, you will see that a rank is like sending something to like the next rank, right? Now, the way to look at this is if, like, for example, say uh, a complete round trip, like a complete step, uh, like this particular step over here, like round one of all reduce, suppose it takes some n milliseconds. Uh, then suppose let's say let's assume let's maybe disturb this thing a bit, right? Say this particular I want to kind of like highlight one box. I'm gonna try out things. I do not know if it's gonna work, but let's see. If I do this and I keep sending it back, send backward, send backward, send backward, guys, send backward. Oh my goodness, there's like so many layers. Okay, so command and this symbol. Okay, so okay. Perfect. Perfect. This was so hard, but I have finally done this, so I'm kind of happy that I was able to do this. So okay, I don't really want a edge to be like this. Maybe And can the opacity be like a little smaller, little lighter, I guess? Okay, this could be good, right? Okay, perfect. So now say that was good. Now say I have this rank, like all of these ranks are gonna be sending their chunk to the next chunk uh, in parallel. Okay, like it's although the sequence diagram makes you think that it's happening sequentially, but this is all happening at the same time. Like the like rank one does not have to wait for rank zero to get the chunk. It's just gonna be like, okay, rank one is gonna send its accumulated chunk to the next rank two in the ring whenever it wants to. So like say rank one uh, takes like say, oh shit, why is it drawing on that thing though? Okay, hold on. Dude, right? Am I? Did I just play myself? Let's say opacity above this, and then maybe I can just like play with the color to here. Is there a way for me? Okay, pink. Fuck this. We'll just go pink, dude. Pink is good. Pink is really good. Okay, perfect. Now, coming back to writing text. Suppose a rank one took like 2 milliseconds to like transfer uh its chunk. Again, I'm just like making up numbers at this point. Say this took 2 milliseconds. Say this dude. Oh my goodness, dude. Say this dude took 3 milliseconds. Okay, you know what? Like I noticed what I did. I mentioned 2 milliseconds, but I wrote 3 milliseconds, so I'm gonna commit to it. And this dude, suppose took 10 milliseconds, and say final dude took 2 milliseconds, for example. Dude, what? Where did that one thing go? Did I just like not copy it well? Okay. And I'm gonna like kind of like expand this a bit below. So like look at just this one tiny snapshot. Now in this tiny snapshot, for one round trip to work well, we know the fastest chunk was that fastest a chunk was sent was like 2 milliseconds, but the slowest chunk was like 10 milliseconds. So now what is gonna happen is let's maybe right here uh, a peak. Okay. Let's say a slice of a uh, nickel operation. So like we're gonna talk about like a slice of a nickel operation, and like this is that oh my goodness, I hate this. I fucking hate this line. Okay, anyways. So this is the slice of that nickel operation, and what's gonna happen in this particular slice is that because you are like sending your chunks across. This is like the slice of that nickel operation, and what's gonna happen here is uh, let's see how long, or rather, the question is like how long does each rank wait to get their data. So let's see, rank zero. Rank zero clearly has to wait 2 milliseconds. Uh, rank one has to wait 3 milliseconds. Rank two has to wait uh, okay 3 milliseconds, and then rank 3 had to wait 10 milliseconds. Now, before we can even go to the next step, all ranks need to have all the data. So, like, even if uh, the fastest chunk transfer happened in 2 milliseconds. Uh, the slowest rank was uh, okay. So the slowest rank was 10 milliseconds. So bottleneck is 10 ms. So all ranks are waiting. So all ranks are waiting. So what this means is, so for whatever reason, so whatever reason it took for like one rank to like, uh, whatever reason it took. Okay, okay, anyway, so whatever reason it there was for like this 10 millisecond delay, uh, every other rank is gonna be waiting. So this now goes back to our very first text dump we had, log dump that we had here, which is you had these n milliseconds, so sorry, n seconds per step, and then one rank decided that, hey, I'm gonna do something really slow, and then across all the ranks, you are gonna see this exact same inflation in your step time. And that's basically what a straggler node is. Uh, that's the uh, so yeah. This is how you understand what straggler nodes are, and you've kind of uh, reached like a straggler node at this point. Uh, but yeah, like this is like the overarching thing. Uh, let's see. Let's go back. Okay, so uh, this was just all of this was just to like build an intuition on why straggler nodes are even uh, a thing. It's like in this like one slice of this nickel operation, you can like see like, okay, if one of these transfer takes like long, it could probably be like this rank 2 versus like Loki like throttled or something, and then you would basically just run into this issue. So now that we have like built the foundation, I am actually gonna try to implement nickel from scratch, and then we will try to actually induce like these faults that cause stragglers. Do note that I'm only gonna focus on like networking related stragglers. There are like way too many, and probably I'll like do more sessions. But I think this one was like a really like important step one in understanding how uh, like breaking down your ML training job into like just three modes, and then understanding what is happening on an actual node when your training is going on. So I'm gonna save my I'm gonna save another diagram. I'm gonna call this NCCL slice. I keep snapshotting my Excalibur like diagrams, because uh, one way it really helps me is one way in which it really helps me is I can, if I am putting together a blog, I can just like load one snapshot that did not have this chunk, and then like I can like it just it's just easier to like make or extract diagrams for your, say, blog or something. Anyways, so that's the general overarching idea, and then now I think I'm just gonna get to the boring part, which is programming something in Rust. So let's try this now. Uh, let's see if I can share my terminal. And this is gonna be like a harder thing to do now, because let's see. Am I showing my terminal? Okay. Okay. So this part is gonna be like much harder because one, I just may completely fail at this implementation, and like at least in the time that I have given myself in this stream, I may completely fail. But I really wanted to like kind of explain to people how stragglers occur, I guess. You know. Uh, anyways, now that we have all of this out of the way, I'm gonna try to get into some code because I am uh, like I have spent considerable amount of time trying to like actually debug a bunch of causes for stragglers, at least on like a network level. So uh, I've done most of my debugging on like a Linux machine, I would say, and I am running on a Mac. So because I'm running on a Mac, um, yeah, let's see. Um, because I'm running on a Mac, I would need some sort of like Linux like utilities, I guess. So what I'm gonna do is two things. Let's see. Okay. Um, Wondering. I'm just like I have a browser. Actually, am I? Oh shit. Okay. Okay. Hold on. I gotta. Um. Okay. Let me go to my OBS thing and then actually just show this. So because I mostly work on Linux machines, I do need uh to like set up like a VM. So I had installed Lima CTL. So this is what I'm going to use to create like a VM and then we'll code inside it. If that makes sense, but I was just Googling this. That is what I wanted to show. But let's see. Uh, which Lima CTL? Okay, I have Lima CTL. So Lima CTL version. Bruh, I don't even know if this flag. Okay, this flag does exist. I'm gonna quickly do an stop. I have some decent amount of space, I guess. So, let's see. Going through the documentation and another uh, tab, but okay. Anyways, let's see. I had created this like directory called nano nickel. It's an empty Git repository. Nothing in here. So first, actually, you know what? This probably creating like an empty Git repo is not going to be uh, useful because I usually just like I plan to write this in Rust, and whenever I'm usually writing anything in the Rust, I usually just do like cargo new and then the project name. I'm thinking. Uh, what am I furiously typing? Yeah. Anyway, so sorry. I was trying to brush up on my Rust. Okay, perfect. I was trying to like brush up on my cargo uh, like commands. So okay, so I've just initialized like a empty uh, I've just initialized like an empty project, and maybe I can see Vim cargo. So let's see. I do not have any dependencies right now, but like one thing that I do want to read up on is so one like I want to like start very simple. Let's go back to. Can I like do like a split screen here maybe somehow? It's fine. I'm gonna do this the old way. Cargo. I think it's called Chrono. Let's see. Okay, so we have cargo chrono. So this is what I want, and I can do this. Okay, let's just do this maybe. Now I can like manually add this shit or uh, let's see. Oops. Okay, and if I check my cargo, dude, come on, dude. Vim cargo, dude, what? Okay, so this did add the dependency correctly. So ls, perfect. So I have this chrono thing just for creating. You know what? Maybe I can just like open up a VS Code rather than this. Let's actually open up VS Code. Let's see. Let's see. Let's see. Let's see. Can I perhaps show VS Code? Okay, I'm gonna set up VS Code on my OBS real quick. Boom. Okay, perfect. Shut up. We do not care about this. Let's maybe use the VS Code browser. Dude, what? What the fuck? Okay, that was weird. Oof. Okay, so we will be raw dogging this. We won't be using any Claude code or anything. So maybe Claude code just to do some like Googling or something maybe. But anyway, so let's go to main RS, and then I'm just gonna start by importing a couple of things. So like like uh, I, I'm thinking like I think the first few things that I would want is like I would want to create like a simple process that does like has like a TCP listener and like a TCP stream, and then I would want to have some sort of uh, uh, like a mock. Uh, what can I how do I put it better in words? Like I would want to have like some sort of like mock process that only focuses on like the network part and not the compute part. Like I do not have GPUs and I should not need GPUs to explain stragglers. So I'm thinking like something very simple, uh, like maybe if I were to like design a say design. I really like doing this. So if I were to like design some sort of tool, okay, something is clearly wrong with my tilde symbol. It keeps defaulting to rupee. But anyway, so like what I would say is like I'd want like my user experience to be like uh, nano nickel, maybe nano nickel, and then I would want to have like a rank, which is like some whatever rank size, and then I would want to have like okay, sorry, whatever rank like which is zero, whatever, and then like world size, some world size 4, and then I would want to pass like the number of steps for it would run, for example, uh, num steps. Dude, what is going on? Okay, steps, and then maybe like some chunk size, like C size, whatever. So like if I am creating a binary, I would want to have like 4 such binaries, something like this, running, and all of them basically should know how to talk to each other, like exchange some like dummy data, and then like that's the general idea. That's what I would want to do. So what I will do first is like create a simple like CLI tool to do this. Uh, like one like each process should be like one rank, like a real GPU in a real cluster. Uh, we tell it like which rank it is, and then yeah, we can just simulate the training steps and then simulate how big the gradient chunks should be and so on. So let's basically do this. I'm gonna first of all import some basic ass things. So wait, first of all, I need to check if people are gonna be able to see this like font size or oof, is this too big? Kind of good, right? Kind of looks good. Maybe maybe the theme needs to be better because I can't see shit here. VS Code dark? Sure, I guess. Sure, I guess maybe I'll get a little less hate if I don't do dark. Okay, so a couple of like standard libraries that I will just keep around. I don't know what I'll do with this, but like um, I can keep like removing things around, I guess. So TCP listener, and then I think oops, then TCP stream, I guess. For now, just this. Like I generally just like to start with like some scaffold. Like it doesn't have to compile, but maybe So struct args, for example. I'm just designing my CLI experience that we like kind of explained here. Like if I want this, right? I want like a rank which is just usize, and maybe we'll have this world size which is usize as well, and then we'll have like steps which will be like usize. Chunk size will be also usize. Cool. So like going back to the design, this is what I have. This is what I would want here. Uh, sure, args is never constructed. Relax, relax. And I'm just gonna create like a function called parse args, and then we'll just be like, hey, this constructs the arguments for us, and then like let's see. So like I want to collect all of these. So let's say args is like a vector of say strings, and then so far it's like an easy thing. So like what I was thinking is uh, we can use um, let's see, is this thing correct? Okay, this is what I want. Now by default, let's say rank is none. Just some initializing it to like some sane defaults, and I want to stick to like the yeah, I want to stick to the nickel explanation that we did early on, and I want to just like have just world size 4 uh, uh, as like the default. We could change it, but that's gonna be my sane default. Then let's see, let mute steps be, I don't know, 500 maybe, I don't know. And let the mutable chunk I just wrote chunk size be, I'm thinking what could be a good size. What is a good size? Like I don't know, 200,000. I don't know. I'm just putting something in here. There's no reason. Okay. So now that we have this, what I would want to do is I'm gonna be like start loop, and then in that loop I'm just gonna start parsing all these arguments. So I'm gonna be like it's gonna be like 1, I guess. Dude, I keep flipping between multiple languages and I keep forgetting to add that semicolon, which is kind of sad. But anyways, so say args are len. So I have multiple args that are gonna be sent to me, and then why is this red? Why is this red? This is args, which is fine. That's fine though. I think that should be okay, I guess. Okay. Okay, this should be good, I guess. Now, no, no, I get it, I get it. That's fine, that's fine. But so okay, I'm thinking, like if I want to have a particular rank, I could just be like sum. If I'm trying to like do that math in my head, so if she should be I plus one, and then like do like a parse. Okay, okay. Okay, okay. So I'm thinking, what am I missing? Sure, it's a vector. So args dot uh sure, I guess. Whatever, I guess. Anyways, I'm just gonna like copy paste these things, and then this one's gonna be for world, this one's gonna step, this one's gonna be for the chunk, and then I need like one which is just incrementing. Okay, this is a very controversial way of writing a loop, I guess, but it's fine. It's fine. Sometimes you just have to be a sinner. So you got this whole size thing here, and then you got these steps things going on here, and then you got these chunk size going on here, and then yeah, I think everything else should just kind of remain the same, right? Except for like we don't need some here, right? Kind of don't need this shit. And same here, we don't need this shit at all. At all, dude. We don't need this shit at all. Okay, perfect. So, okay. And then this is good. I missed a semicolon here. Wait, where am I missing a semicolon, dude? What does it mean? Am I tripping or like is this thing tripping? Because like this let me parse args function, right? Whatever, I guess we'll figure it out. I'm gonna be like, hey, is required whatever, and then we just want to have, and then steps, and then chunk. Oops, chunk size, cool. And one final comma over here, right? I'm doing something silly, I guess, because oopsie daisy. what is it that I am missing here? Like, am I just like fucking up on my Rust syntax? Hmm. I'm just googling, but let's see. Anyways, I do not understand why Rust Analyzer is being like a dick right now, but it's fine. We'll figure it out. Like, I think it's just angry that um, I'm being like low key evil, but that's fine. That's fine. That's fine. Okay, so this is just parsing the arguments, I guess, at this point. We'll come to this later. Okay, so I'm just gonna like create some dummy functions. Fn. Okay, so queue size. Okay, format, and then IP. I'm just gonna come up with like some random IP, I guess. I'm gonna be like random plus one, like fake IP. Okay, like it's fine. It's fine. Like we don't really have to worry too much about this. And I'm gonna have like some constant port for U16 of whatever. I'm kind of like debating if I should even be like writing this from scratch though. You know, like do I need to? Like do I need to though? Like that's the whole point, right? Like that's the whole point of um, that's the whole point of like LLMs, right? Like sure, I could spend time writing all of this code, or I could like write a very detailed description and get Claude to write this, and then I could like kind of like spend the remaining amount of time actually just yeah, I could spend like remaining amount of time just actually like messing with that particular um, like simulation, and then kind of show how stragglers occur. Right, I could do that, I guess. I guess. Anyways, I think I'm gonna head out and grab some food, but I think I'll probably end my lunch. Sorry, I'm probably gonna end my stream here. I'll call this like part one, and then in part two, I think we'll focus on implementing Nickel from scratch, and then probably we'll come back and then like see what else we need to do. I guess. Cool, fellas. I'm gonna end the stream here. But I wanna like kind of show this cool thing right here, bro. Boom. Okay. I'm gonna end the stream right here, and then probably convert this into a blog, and then probably just place this into a. I'll probably continue again from the next stream onwards. Cool. Stopping the stream.